The cells in your body are like tiny floppy soap bubbles, and yet here you are, still all in one piece without going pop 100 trillion times. So why is that? It's all down to your microtubules. Microtubules are the tentpoles that give stability and rigidity to your cells. They're made up of a protein called tubulin, which comes in two flavors, alpha and beta. Alpha and beta tubulin bind together in what we call a dimer, and that dimer binds to other dimers until you get a spiral that goes all the way around. It takes 13 dimers, or 26 tubulin proteins, to make one cycle, so for a single microtubule you easily need more than 1,000 individual tubulin proteins. So how are these microtubules made? Well, piece by piece. If one microtubule needs thousands of proteins, that means that every cell must have many copies of both alpha and beta tubulin. Since alpha and beta tubulin only bind to one another in a very specific orientation, they automatically assemble in the right way to form a microtubule that can dynamically extend. Now you'd think these tentpoles would get in the way every time a cell needs to change shape or move somewhere. But fortunately for us, microtubules are dynamic. This means that they're also a touch unstable. Microtubules can start to disassemble in what is known as a catastrophe. After having grown for a bit, they're able to suddenly fall apart and peel off as individual filaments. But that's only part of the microtubule story. Microtubules are also the railroads of a cell. The inside of your cells is made up of a thick salty liquid called the cytosol. Inside it, loads and loads of proteins float around until they happen to arrive wherever it is that they kind of wanted to go to. So what happens when proteins have a very specific place that they want to go to, that they wouldn't easily reach by floating around and randomly bouncing off of other proteins? This is where the microtubules come back in. Because they form a network that goes pretty much anywhere in a cell, and because they're generally quite sturdy, microtubules are the train tracks that you can transport cargo down. Cellular cargo needs a molecular freight train to carry it along the microtubules, and that is a protein called kinesin. Kinesin is able to bind to tubulin with its two feet-like motor domains and slowly work its way up the microtubule to deliver its protein cargo. So, microtubules, tentpoles, railroads, and pretty much all-round amazing.